So a quick review of multiplication for A times B. I'll just do that one quick. You're going to have, because A is a 2 by 2 and B has 2 rows and 3 columns, you're going to get an answer that's a 2 by 3. I'll do it up here because I have the answer underneath, and if I click on it, it'll just screw everything up. So to find this one, position 1, 1, you're going to take, row 1, because it's always row times columns, row 1 and multiply it by column 1. So take that row, turn it aside, 1 hits a 2, 0 hits a 2, 2 plus 0 is 2, and that's how you get that one. To get this second one, that is still in row 1, but it is in column 2, so I would take row 1 and column 2, turn it, multiply it, and I'm going to get negative 1 plus 0, which is negative 1. To get the third one, this position right here is row 1, column 3. So I take row 1 and multiply it by column 3. And 1 times negative 1 is negative 1. And 0 times negative 3 is 0. Add those up, and you get negative 1. Running out of colors. For this one right here, that is in row 2, column 1. 2 times 2 is 4. 6 times 2 is 12. Add those up, and you get 16. And just to use up as many colors as possible, the best color in the world, bright yellow, negative 2. And finally, just to confuse things a little bit, we're going to use a dotted line, thick dotted line. 2 times negative 1 will be negative 2, and negative 18 will give us negative 20. Perfect. And we'll check it, and there it is. So you've done the rest of these already. If you haven't done them, you should pause the video at this moment and do them so that you can see what your answers are going to be. B times C. Okay, you guys have to ooh after each one. All right. C times A. B times A. Oh. Aw. A squared. And A times B times C. Whew. Very nice. I once had a class where I actually had like ooh on a piece of paper and ah on another piece of paper, and then I could direct the crowd to have the right kind of noises. Very exciting. So we see in some of these, like in particular, we have A times B here and B times A here, that it is different when we reverse the order. In mathematics, there's a name for that. There's a name for when you can multiply things like 5 times 3 is the same times as 3 times 5. Just highlight that word. These are some fancy math words. There's associative property of mathematics, commutative property of mathematics, and this one, the fact that it doesn't have the same result means it's not commutative. So here are our general rules for matrix multiplication. And here are the fancy words, commutative. It is associative, meaning that when you are multiplying 3 things together, you can either do the first 2, A times B, and then multiply by C, or you could have done B times C and then multiplied by A. You can distribute. So if you have 2 matrices added together and then you're multiplying by another matrix, you could, if you wanted to, multiply twice first and then add. Of course, I'd probably recommend adding first because multiplying is what takes so long. But if you wanted to do it a longer way, you could. And remember, we have an identity. We talked about it, all the 1s being on the diagonal. Now, when you multiply by that, that matrix keeps things the same. And the identity exists only when it's a square matrix. Yes?
When I would have like the example where we are factoring the one out, when you would have instead of AB plus AC, let's see we have, let's say we have AB plus CB.
Like this?
No, I couldn't say B times A plus C.
No, but you could say,
A plus B.
and so when you factor it out, now you can't just factor it out in front, but you could factor it out behind.
So it depends where I put it.
Yes, because of this one. It is weird to get used to that. The only thing that you're allowed to multiply in the front or the back, and it doesn't make a difference, is if you multiply by an inverse. Okay, now with numbers, this would be like multiplying by 1/3. What happens when I multiply 3 by 1/3? I get 1. The same thing happens with an inverse. The inverse is when you multiply it, you're going to get the identity matrix.